Here we are. It's our final answer key. It's our final activity for you. Let's get into it. Remember, this is straight from, well, not exactly straight from, I corrected myself on that, but it's pretty much from the text. So I only wrote, I think, one of these questions, maybe two of them, and you get to use a calculator. So make sure as you're going through them to get your calculator. As usual, I'm going to be using Desmos because I don't have a TI-84. I guess I do have one, but I like Desmos more. Anyways, let's get into it. Factor x squared plus 9x plus 14. That's x plus 7, x plus 2. Easy. Hence, solve this equation. X plus 7 times x plus 2 equals 0. Zero product property tells me this is true, and this is true. Done. Solve this, giving your answers exactly into 4 significant figures. So this tells me that I'm not going to get a nice, pretty response, and that is quite alright. But this tells me that I can't just use like a graphing thing to get an answer. I need to actually solve this thing algebraically. So most of you probably would want a quadratic formula since you can't factor it. So let's just go with that. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That means x is equal to negative 4 plus or minus the square root of 16 minus 8 all over 2. X equals negative 4 plus or minus the square root of 8 over 2. Negative 4 plus or minus 2 root 2 over 2. And that's negative 2 plus or minus the square root of 2. I don't know if you need to do this last step for the IB, but I would do it. And then to get my approximates, use the calculator. Negative 2 plus the square root, not in all caps, the square root of 2, and that is x is approximately negative 0.5858. And now let's do the negative one. Or x is approximately negative 3.414. Both of those, I believe, are 4 significant figures. Moving on, paired bivariate data xy is given in the table below. It represents the height x meters and lengths y and I don't know, whatever the hell this thing says. Okay, so calculate the Pearson product moment correlation coefficient for these data. Again, this is just a calculator problem. So if you're using Desmos, you got to enter the table. If you're using a TI-84, you use the table feature in there. 2.8, 1.8, 2.0, 2.2, 3.0, 3.4. Oh, I should have my formula booklet open too, shouldn't I? Like, I know all these formulas off the top of my head. I do not. 2.3, 3.1, 2.7, and then y1 is approximately a x1 plus b. Alright, so using my calculator for part A, I got that r is equal to 0.85. State the type of linear correlation. It's strong and it's positive, or it is pretty strong and positive. Calculate the y on x line of best fit. Again, that's just using either your TI-84 or Desmos, and I got y is approximately 0.937, x plus 0.242. Moving on with my life. Paired bivariate data xy that is strongly correlated has a y on x line of best fit of y equals mx plus c. When x equals 70, an estimate for y is 100. When x equals 100, an estimate for y is 140. We need to find m and c. So this is just a system of equations here. So we have 100 is equal to m times 70 plus c. And our second equation is 140 is equal to m times 140 plus c. I'm going to really quickly rewrite these to not look so stupid and do 70m and 140m. Well, there's lots of different ways that we can solve the system. I'm going to subtract one equation from the other, so that gets me negative 40 equals negative 70m. Dividing by negative 70 That's going to get me 4/7 is equal to m. And that means that I can figure out what c is. 100 is equal to 70 times 4/7 plus c. I'm going to use my calculator here and do 100 minus 70 times 4/7, and that means that c is equal to 60. Great, so finish part A. Let's change our color here and go on to part B. State if there's a positive or negative correlation, okay? Since our slope is positive, the correlation is positive too. As our x increases, our y increases, which means we have a positive correlation. The value of x bar is 90. Find the value of y bar. Remember that x bar, comma y bar is on the line. That's by construction of the linear regression stuff. So that just means that we're going to say that y is equal to 4/7 times 90 plus 60. And again, I'm going to use my calculator to evaluate that because that sounds way easier than doing any sort of calculation on my own. And why make my life hard when I can make it easy? And I got y is approximately 111. When x is 60, find an estimate for the value of y, given that this is interpolation. Again, the fact that it's interpolation just means that it's reliable and we can do it. And that means we're going to say y equals 4/7 times 60 plus 60. And again, just using my calculator, that means that y is approximately 94.3. Lovely. This is one of the ones that, no, I didn't even write this one. I just took it from a different chapter. Just kidding. An architect wants to design a rectangular water tank with an open top that can hold a capacity of 10 meters cubed. The material needed for the tank costs $10 per square meter for the base and $6 per square meter for the sides. The length of the base must be twice its width. The minimum cost of material required to build the container, or find the minimum cost. Okay, so let's sketch this thing here out. Here is our water container thing. Let's call this x, and it says the length has to be twice that, so that's 2x. And then we have our height. So we know that our volume is equal to base times height, which in this case we know 10 is equal to x times 2x times h, or 10 is equal to 2x squared h. Okay, and now we need to find a separate expression for our surface area. Our surface area is going to be the area of the bottom, 2x squared plus 2 times 2x times h plus 2 times x times h. In other words, 2x squared plus 4xh plus 2xh, or 2x squared plus 6xh equals the surface area. Alright, so we got a bunch of stuff going on here. However, we're not interested in minimizing our surface area thing necessarily. We're particularly interested in minimizing the cost. So this is $10 per square meter for the base. This part here represents the base, and it was $6 per square meter for the sides, and this part here represents the sides. So let's figure out our actual cost. So then the cost is going to be 10 per these things plus $6 per these things for 20x squared plus 36xh. Now we would love to be able to optimize this using calculus, but I have x and h in here. So I'm going to come back over to my, not velocity, my volume thing, and I'm going to solve for h. So 10 over 2x squared, which is equal to 5 over x squared, is equal to h. And that is going to be substituted in right here to make it so our cost equation only has one variable in it. So let's go ahead and do that. That's 20x squared plus 36x, and then instead of h, we're putting 5 over x squared in there. This is going to get us 20x squared plus 36 times 5 is 150, 180, then over x. And now we need to optimize that. So we'll call this c of x. That means that c prime of x is going to be equal to 40x. Where'd my PowerPoint go? That was bizarre. All my stuff's gone. Okay. Let's see. We do know that c of x was equal to 20x squared plus... Well, I don't even remember what that was. 36 times 5, I think, was on the top, which was 180. Let me double check that. Yep. 180 over x, which means that c prime of x is going to be equal to 40x squared minus 180 over x squared. To optimize, we're going to turn that into a 0 on the c prime side and solve. So that means that we're going to get, multiply everything by x squared. Why not? 0 equals 40x to the 4th power minus 180. So 180 equals 40x to the 4th power. Divide by 40. What is 180 divided by 40? 4.5, or 9 halves, is equal to x to the 4th power. Take the 4th root of that, 4.5 raised to the 1/4 power, and x is approximately 1.46. Alright, now we're told to find the minimum cost of the materials. So if our cost function is 20x squared plus 180 over x, and x should be 1.46, we can just type that whole thing on into a calculator. Let's see here. Oh, Jesus. We got 20 times our x value squared plus 180 divided by that value, and I got we're doing c of 1.46. I got that was equal to $166.01. Good for us. All right. An object is moving in a straight line away from a fixed point with position s of t is equal to negative 3t squared plus 4t plus 22 meters from the object after t seconds. What is the object's initial distance from the origin? That means we want to figure out what is the position at time 0, which is 22 meters. Lovely. An object is moving, same thing. What is the total distance traveled by the object in the first 2 seconds? So I need to first figure out if this thing turns around somewhere. Please bear in mind that this is a calculated portion of the test, so I'm going to graph this thing. I'm going to say y is equal to negative 3 x squared plus 4x plus 22. And I can see that in the first 2 seconds, this thing does in fact turn around. In fact, at 2/3 of a second, this thing turns around. So at t equals 2/3, y is equal to 23 1/3, which means that in the first 2/3 of a second, we have gone some amount of time. And then at t equals 2 seconds, our y value is at 18, I want to say. It's what it looks like to me. A little bit over 18. Just kidding. 18 exactly. And so that means that in the first 2/3 of a second, this object goes 1 1/3 meters. And then to go from 23 1/3 down to 18, we go down 5 1/3, which means total, this thing has gone 6 2/3 meters. Or, I prefer 20/3, but whatever you want to do with your life. What is the object's speed the instant it is at this fixed point, at this origin? So that means that we need to figure out when is the thing even there. So I'm going to set this distance equal to 0 and solve. Again, this is the calculator portion of the test. I'm going to solve it using the graphing utility, and I can figure out that this happens when t is equal to 3.456. And now I need to figure out the speed at this time, so my velocity function is negative 6t squared plus 4. I take that back. That is not what my velocity function is. It's negative 6t plus 4. And now find v of 3.456. And that's going to be, according to my calculator, negative 6 times 3.456 plus 4. Negative 16.73 meters, I guess it is, huh? Per second. Lovely. Find the constant term in this expansion here. Whatever your term is going to be 6, choose r, x to the 6 minus r. Let me fix that. Times 2 over x to the r power. All right. We can do a little bit of simplifying here. 6, choose r, x to the 6 minus r, that's 2 to the r, that is x to the negative 2r. This does not look like an r. Let's combine some more stuff. This means we get 6, choose r, x to the 6 minus r minus 2r times 2 to the r, or 6, choose r times 2 to the r times x to the 6 minus 3r. If this is a constant term, we need this guy right here to equal 0. So if we have 6 minus 3r equals 0, 6 equals 3r, 2 is equal to r. Plugging that back in, we get 6, choose 2 times 2 squared. 6, choose 2 is 6 squared over 2 squared times, not squared, factorial, what am I saying? 6 times 5 times 4 factorial over 2, that's 30 over 2, which is 15, times 4, which is equal to 60. Lovely. Data is collected from 10 football teams in the same league. The amount that each team spent on players' wages, W, in millions of pounds, and the number of goals, G, that the team scored is recorded in the following table. For the amount spent on wages, calculate the mean and the standard deviation. All right, use your calculator. Summary statistics calculator. Enter my data. I'm doing it for wages. That's 200. That's 185. 190. 150. 160. 120. 50. 100. 40. And then 10. Let's go ahead and calculate. My mean that I got, I guess it should be W bar in this case, was 120.5. And the standard deviation that I got was 64.7. For the goals scored, do the same thing. Who's surprised by that move? I know, I'm not. That's 92, 87, 85, 81, 74, 69, 62, 54, 41, and 32. Let's calculate everything. This time, my mean, my G bar was equal to 67.7, and my sigma G, my standard deviation, was 19.2. All right, now we need to find the Pearson, the line of best fit R stuff. Back over to Desmos, set my table up. So much fun. I hope that someone out there has got some good summer plans. I know it's a little hard to do planning when you're a child and not just free to go about the world and do whatever you want. Yeah, it's hard to do planning when there's still a global pandemic happening, but I hope you have something good to do with your time. It'd be real shame if you just had nothing, I guess. I don't know. Maybe you like doing nothing. Maybe I shouldn't judge other people's lifestyles. I don't know. Maybe I should just stop talking and just do math. I'm currently typing numbers into my calculator, in case you're wondering why I'm just talking about stupid stuff. I'm sure you were. Anyways, y1 is approximately equal to a x1 plus b. According to this, let's change colors here. R is approximately 0.94. I guess it should be rounded to 9.5. 9.5. Describe it in 2 words. It's strong and positive. And the line of best fit here, this linear regression line, is G is equal to 0.282 W plus 33.7. That's right. Another club in the same league spent £80 million on a player's wages. Estimate to the nearest integer the number of goals that they would score. All right, that's just using our linear regression line here. G is equal to 0.282 times 80 mil, or just 80 in this case, plus 33.7. So if we're doing 0.282, $80 million or pounds is pretty close to what I make if you get rid of a bunch of zeros and change all the numbers, in case you were curious. This person should make 56 goals. I don't know if that's good or not. How many do people do? Yet another club in the same league scored 17 goals. Give 2 comments on the validity of using the answer from C3 to estimate it. Give 2 comments. Okay. Well, that's much lower than other clubs. So it's extrapolation, which can be risky. However, our correlation is quite high, so it might be better than other extrapolation cases. I don't know what kind of things we're looking for that. That's what I would say. Maximum mark 13. A function is defined by f of x is equal to 6x plus 3 over 2x minus 10, where x is a real number and not the number 5. Write down the equation of the vertical asymptote. Write down the equation of the horizontal asymptote. For our vertical asymptote, we're going to set our denominator equal to 0. 2x minus 10 equals 0. X equals 5 is the vertical asymptote. For a horizontal asymptote, I'm going to look at the ratio of the leading coefficients. And y is equal to 6 over 2 equals 3 is my horizontal asymptote. Sweet. Moving on. Write down the y-intercept and the x-intercept. So to find the y-intercept, f of 0 is equal to 3 over negative 10. So it's 0 comma negative 3/10. To find our x-intercept, we need to set the top equal to 0. That means 6x equals negative 3, x equals negative 1/2, and it's the point negative 1/2, comma 0. Please put these things as ordered pairs like that, not just a single value. Part C says to find f prime of x. This is a quotient rule. So u of x is 6. Actually, I'm going to do the top, low-y high, high-y low kind of business. So f prime of x is high d low minus low d high all over low squared, which is going to be equal to 12x plus 6 minus 12x plus 60 all over 2x minus 10 squared, which is going to be equal to 66 over 2x minus 10 squared. Isn't that fun? State what this indicates about the graph of f of x. Okay, this tells me that the this denominator is always positive, and 66 is always positive. So since f prime of x is positive for the whole domain, f of x is increasing on the whole domain. Sketch the graph of f of x showing the information found in A, B, and C. What could possibly go wrong? Alright, so my vertical asymptote I got was x equals 5. My horizontal asymptote was y equals 3. We had, where are my other points at? Those two things. In part B, we had these axes intercepts. We had negative 1/2, 0. We had 0, negative 3/10. This does not look like it's lining up with what I said about our derivative. Did I do something wrong taking my derivative? I don't think that I did. I mean, we should end up with something that looks like this, which clearly does not line up with what I said. Why is that? I don't know why that is. So what happens when I do things for the first time here in front of you? State what this indicates about the graph of it's low, d high, minus high, d low, all over low square. 6x plus 6, 12x plus 6, minus 12, minus negative 60 is plus 60. I don't know what to tell y'all about that right now. Let me graph this original thing. Y equals 6x plus 3 over 2x minus 10. Yeah, it certainly isn't increasing over the entire domain. In fact, it's decreasing over the entire domain. Let's see what happened there. Oh, you know what I did here, I think? It's supposed to be low d high minus high d low. Yep, I messed up that thing. Look at that. That's why you use your formula booklets. Boom. Swap that stuff. That should be negative. Since this is, well, that's embarrassing. Look at that. It's good modeling, though. Even I make mistakes. And that means that our thing is not increasing, but decreasing. And that does, in fact, fit with the graph that we have. Fantastic. All right. Moving on to our last and final part here. Write down the equation of the tangent to the curve at the point where x is equal to 2. Let's try to carve out some room over here for me to do that. We're going to find f prime of 2, which is going to be negative 66 over 4 minus 10 squared, which is negative 66 over 36, which is negative 11 sixths. So we have y equals negative 11 6 x plus b. And in order to figure out what b is, we also need to figure out what is f of 2. So f of 2 is equal to 12 plus 3 over 4 minus 10, which is 15 sixths, which is divide both by 3. That's 5 halves. Okay, so that means that we get 5 halves is equal to negative 11 sixths times 2 plus b. 5 halves minus plus 11 thirds equals b. That's 10 sixths plus 22 sixths equals 32 sixths equals b. So y is equal to negative 11 6x plus, that's what, 16 thirds. Lovely. Anna invests $200 in a bank account that gives a compound interest rate of 5% per year. After 3 years, how much is she going to have? So y is equal to 200 times 1.05 raised to the third power. Open up my calculator. 200 times 1.05 raised to the third power. She'll have $231.53. Great. How long is it going to take her money to double? So we got to calculate that. Oh, that's part 2 here, I guess, isn't it? Calculate how many years. So that means that we're looking at 400 equals 200, 1.05 to the x. That's 2 equals 1.05 to the x. That's a log thing. Log base 1.05 of 2 equals x. I don't know why I wrote 1x. If you need to use a calculator, you might want to use change of base formula, which is log 2 over log 1.05, which is log 2 divided by log 1.05, 14.2 years. Anna wishes to buy a mountain bike which costs $350 but is depreciating at a, I think they messed this formatting up here. Anna wishes to buy a mountain bike which costs $350 but is depreciating at a value of $6 per year. Calculate how many complete years it'll take for the bike to cost less than $300. All right, let's change colors here. We're going to a bike. We got y is equal to 350, but it's depreciating, so we're losing 6%, so 9.4 to the x. I want to know when that's going to cost less than 300. I'm just going to use a calculator here. Y is equal to 300 times 0.94 raised to the x power, and I'm going to look for when is this number less than 300. Oh, I'm sorry, that's supposed to be 350, not 3. I typed it into my calculator wrong. Looks like it does not take that long. After 2 years, it's still a little bit too high, but that means after 3 years. So 3 complete years. Whoops, that is not what I meant to do. So after 3 years, it's going to be less than that. Calculate how many complete years it'll take until Anna can afford the bike. All right, so that means that we're going to have to set these two equations equal to each other and solve. So we're going to set that equal to that. We're going to say that y, not y, we don't need that anymore. We're going to say that 350 times 0.94 to the x has to be equal to 200 times 1.05 to the x. I suppose I'm really looking for when one is larger than the other, but it's going to be helpful to maybe do it like this. Y equals 350, 0.94 raised to the x, and at the same time, y is equal to 200 times 1.05 raised to the x. And I need to see after how many complete years is the second one bigger. Will they intersect at 5.057 years, which means it's going to take 6 whole years. So 6 complete years to afford bike. If after 2 years the interest rate changes to only 2% and the depreciation rate changes to 4%, calculate how many complete years from which you first invested $200 it'll now take until Anna can afford the bike? This is an absolutely obnoxious question. And if after 2 years the interest rate changes to only 2%, okay. So then I need to figure out what her account is worth after 2 years. Which is 220.5. I also need to know how much the bike is going to be after 2 years. Let's change that to orange down here. Y is equal to 350, 0.96 squared. Why would the depreciation rate change? I don't see that happening, but whatever. And that one's equal to 309.26. So after 2 years, we're going to get this new set of equations. We're going to get y is equal to 220.5 times 1.02 raised to the x, and y equals 309.26 times 0.96 raised to the x. And again, I'm going to do the same thing. I need to see when one of these overtakes the other one. So y equals 220.5 times 1.02 raised to the x. Y is equal to 309.26 times 0.96 raised to the x. They intersect at 5.58. So after 6 years of this case, she can afford it. But 2 years have already passed. But 2 years passed before we got here. So 8 years